This is Module 2, Production Part 4. So today we will discuss technical progress and its implications. That means how technical progress will affect the requirement of labor and capital. So that we can represent with the help of Isoquatns and different types of technical progress, that is labor augmenting, capital augmenting, neutral, etc. Then next we will discuss how we can use Isoquatns to represent different returns to scale. Under returns to scale we have studied increasing returns to scale, constant returns to scale and decreasing returns to scale. How these three returns to scales can be represented with the help of Isoquatns. And finally we will discuss Cobb-Douglas production function. Then first, technical progress and its implications. See, when there is a change in technology, actually what happens? The production function also changes. That means there will be an upward shift in the production function, which means that we can produce more output with the same level of inputs. So when there is an upward shift, when there is a technological improvement, there will be an upward shift in production function. That means with the same level of inputs, we can produce more output. Or we can say, when there is a technical progress, there will be a downward shifting of the isoquant. The isoquants will shift downwards. That indicates we need less labor and capital to produce the same level of output. So this we will analyze. Then again, technical progress can be embodied or disembodied. So what is the meaning of embodied technical progress and disembodied technical progress? Technical progress is embodied or investment specific when we introduce new capital or machinery. Suppose we are making more investment, we are purchasing a new machine, so and with the help of that we are producing more output. That is embodied or investment specific technical progress. So there is some new machinery or something new we are applying, especially machinery and machinery or that kind of things. But in the case of disembodied technical progress, what we are doing, that is investment neutral. That means we are not making any additional investment. But with the help of research, we are finding some ways to decrease the quantities of inputs or to decrease the cost of production by reducing the amount of labor and capital employed. So that is with the help of some inventions. So we are doing research and finding some new methods that help us to reduce the requirement of inputs. So there we are not making further investment or additional investment on machinery or that kind of things, but we are getting more output by way of innovations through research. So that is the meaning of embodied and disembodied technical progress. Then mainly there are three types of technical progress. The first one is neutral technical progress. Neutral technical progress means because of the improvement in technology, the marginal product of labor and marginal product of capital increases at the same rate, or the increase is same. The marginal product of labor increases, the marginal product of capital also increases because of the new technology or the improvement in technology, but both the increase is at the same rate, or there is same increase or equal increase in the marginal product of labor and marginal product of capital. That is neutral technical progress. See, when there is neutral technical progress, what happens to the isoquants, or how the isoquant shifts, that I will show you later. Then labor augmenting, second one is labor augmenting technical progress. It means that the marginal product of labor increases faster than the marginal product of capital. So because of the new technology, of course, there is an increase in the marginal product of labor and capital, but the increase in the marginal product of labor is much faster or greater when compared to the increase in the marginal product of capital. So that is labor augmenting technical progress, or we can save more labor to, when you produce the same level of output. So that is labor augmenting technical progress. Then what is capital augmenting technical progress? Here the increase in marginal product of capital will be faster than the increase in the marginal product of labor. That means we are able to save more capital because of the technical progress to produce the same level of output. So, or here also the marginal product of labor and capital increases, but the increase in the marginal product of capital is at a higher rate or at a faster rate when compared to the increase in marginal product of labor. So how we can represent these three: neutral technical progress, labor augmenting technical progress, and capital augmenting technical progress with the help of isoquants. When there is neutral technical progress, there will be a parallel downward shifting of the isoquants. So this is the first isoquant. We are producing 100 units of output, and because of the technological progress, this isoquant shifts downwards. So that is a parallel shift, or the slope of the isoquants remains the same. So there will be a parallel shifting of the isoquants. That is neutral technical progress. So here the slope of the isoquant, the first one and the second one, that will be the same. That means at the same rate we can save labor and capital when you produce the same 100 units of output. So that is neutral technical progress. Then next one, labor augmenting technical progress. See, in that case, this will be the shape of the isoquant, the new isoquant. So this is the first isoquant. We are producing 100 units of output. When because of the labor augmenting technical progress, the isoquant will come like this. So this will be the new isoquant. So from this isoquant we can see that the marginal productivity of labor is increasing at a higher rate, because for producing the same 100 units of output, we are able to produce the same 100 units of output with less amount of labor, or we are able to save more labor for producing 100 units of output. Since the marginal productivity of labor is increasing at a faster rate, that means from 1 unit of labor we are getting a higher level of output. So because of that, the producer can use more of labor when compared to capital. The producer is able to use more of labor because its productivity is high now. So that is why it is called labor augmenting technical progress. And in this case, the isoquant is becoming more steeper. So when there is labor augmenting technical progress, the isoquant becomes more steeper. Then the last one is capital augmenting technical progress. So in that case, what happens to the isoquant? So this is the first isoquant which produce 100 units of output. Then for the second isoquant will be drawn like this. So this will be the second isoquant. That means we can see that we are able to save more of capital since the productivity of capital is increasing at a faster rate. We are able to produce with less of capital this 100 units of output. So since the productivity of capital is high, the producer will use more of capital to produce the output. So that is why it is called capital augmenting. And because of that, the isoquant becomes more flatter. And here the isoquant becomes more flatter. So these are the ways in which we can represent these three types of technical progress with the help of isoquants. The diagram is shown here. From the diagram we can understand what I have explained now. Then next is isoquants and different returns to scales. So in returns to scale, we have seen that in the beginning a producer will get increasing returns to scale, then constant returns to scale, and then decreasing returns to scale. So how we can represent increasing returns to scale, constant returns to scale, and decreasing returns to scale with the help of isoquants? See, first, what is the meaning of increasing returns to scale? Increasing returns to scale means the output increases at a greater proportion than the increasing inputs. See, if the first diagram, we can see for the first 100 units of output, the first 100 units, we need 3 units of capital and 3 units of labor. That is, at point A, we can see that. At a point A, it shows that we need, that is the least cost combination. Suppose that is the least cost combination. Then at point A, we need 3 units of capital and 3 units of labor. Now, suppose there is increasing returns to scale. Now, this is the stage of increasing returns to scale. See, the next 100 units, when the output becomes 200 units, how many additional units of labor and capital we need? See, capital that becomes 5. That means from there is an increase of 2 units. 3 becomes 5. Before we were using 3 units of capital. Now we are using 5 units of capital. Similarly, before we were using 3 units of labor. Now we are using 5 units of labor. Now additionally we are using 2 units of capital and 2 units of labor. Then we are able to produce additional 100 units of output. Because for the first 100 units we were using 3 units of capital and 3 units of labor. Now we can see when we increase the output to 300 units, that means again an addition of 100 units of output. How many additional units of labor and capital are required? Just only 1. 5 becomes 6. So with the help of additional 1 unit of labor and 1 unit of capital, we are able to produce additional 100 units of output. That means the gap between the isoquants, that is decreasing. So we need less and less of inputs or labor and capital to produce the additional 100 units of output. So that shows the increasing returns to scale with the help of isoquants. Then constant returns to scale. Constant returns to scale means the inputs and output increases at the same proportion. So here we can see the first 100 units of output, again 3 units of capital and 3 units of labor. Next 100 units, or the total output becomes 200. Additionally, we are using 3 units of capital and 3 units of labor. That means there is an equal increase in labor and capital. So here the increase in inputs and increase in output both are at the same proportion. Again, when the output increases from 200 to 300 units, again 3 more units of labor and capital are required, or the gap between the isoquants that remains the same. That is constant returns to scale. In this way, we can represent constant returns to scale with the help of isoquants. Then there is decreasing returns to scale. When there is a decreasing returns to scale, what happens? We need more and more units of labor and capital to produce additional 100 units of output. So first, suppose we need only 2 units of capital and 2 units of labor to produce 100 units of output. See, the next 100 units, we need additional 3 units of capital and 3 units of labor. Then the total output increases from 200 to 300 units. That is an additional 100 units of output we are able to produce with the help of an additional 4 units of capital and 4 units of labor. That means the requirement of inputs increases. So this is decreasing returns to scale. In this way, we can represent these 3 returns to scales with the help of isoquants. So if a question is asked like what I explained returns to scale, then you can or you have to represent the 3 returns to scales with the help of isoquants in this way. It will be very easy for you. Then the last topic in this chapter or in the topic production, that is Cobb-Douglas production function. So you know what is a production function, and Cobb-Douglas production function is widely used to represent the technological relationship. So production function is the technological relationship between inputs and output, and Cobb-Douglas production function is used to show the relationship between the amounts of 2 inputs, that is mainly labor and capital, and its relation with the output. Then in its basic form or in its standard form, the Cobb-Douglas production function can be written as Q equals A into L raised to alpha K raised to beta. This is the standard form of Cobb-Douglas production function. Then what is Q, what is A, L, K, alpha and beta? Q is the total output. So total output equals, or it is a function of A, L, K, alpha and beta. So what is A? A is the total factor productivity. Total factor productivity. It depends on your technology. So how much output you are getting from these 2 inputs that you are using, it depends on your technology. When you are using a better technology, the value of A will be higher. So that is A, that is the total factor productivity. How much output we are getting from 1 unit of labor and capital, that is represented by A. Then what is L? L is the labor, and K is the amount of capital that we are using. So what are alpha and beta? They are very important. So what is alpha and what is beta? Alpha and beta are output elasticities of labor and capital. So what is output elasticity? Output elasticity means it measures the responsiveness of output to a change in quantities of either labor or capital. So that means when there is a alpha and beta represents the change in output when there is a change in the quantity of labor or capital is used in production. When we increase the labor, what will be the increase in output? That is represented by alpha. and beta represents the change in output when there is a change in capital. Or we can say, suppose the value of alpha is 0.45. If the value of alpha is 0.45, it means that when we make 1% increase in, we are making 1% increase in labor, keeping our capital constant. What I am saying, there is 1% increase in labor and capital remains constant. Then how much is the increase in output? That is represented by alpha. So if the value of alpha is 0.45, that shows that when we are increasing labor by 1%, keeping capital constant, there will be a 0.45% increase in output. That is the meaning of alpha. And similarly, if the value of beta is 0.55, that means when you increase the amount of capital by 1%, keeping labor constant, then the output will increase by 0.55%. That is the meaning of alpha and beta. Or in short, we can say alpha represents the percentage increase in output when there is 1% increase in labor, keeping capital constant, and beta the other way. So that is alpha and beta, or the output elasticities of labor and capital. Then another thing, Cobb-Douglas production function is a homogeneous production function. So what is homogeneous production function? So we know that a Cobb-Douglas production function is written as Q equals A into L raised to alpha K raised to beta. Then why it is a homogeneous production function? If we are multiplying labor and capital by lambda, that means there is an increase in labor by lambda times and capital also by lambda times, then your output will increase by lambda raised to alpha plus beta. So that is why the Cobb-Douglas production function is a homogeneous production function of degree alpha plus beta. So what I said, when there is an increase in labor and capital by lambda times, or labor and capital increases by lambda times, or we are multiplying labor and capital by lambda, the output will increase by lambda raised to alpha plus beta. So we can say the Cobb-Douglas production function is a homogeneous production function. Then again, the Cobb-Douglas production function is linearly homogeneous. Why? Because in Cobb-Douglas production function, always the value of alpha plus beta will be equal to 1. Since the value of alpha plus beta is equal to 1, if you multiply labor and capital by lambda, then output will increase by lambda raised to alpha plus beta. That means lambda raised to 1, that is equal to lambda. So in short, we can say when labor and capital are multiplied by lambda, our output will also increase by lambda times. That is why the Cobb-Douglas production function is linearly homogeneous. And that means what is the meaning of alpha plus beta is equal to 1? That means if you increase labor and capital by 10%, your output will also increase by 10%. So this shows constant returns to scale. So Cobb-Douglas production function always gives constant returns to scales because alpha plus beta is equal to 1. If alpha plus beta is greater than 1, it shows, what is the meaning of that? If you increase labor and capital by 10%, your output will increase by more than 10%, greater than 10%. So that means when alpha plus beta is greater than 1, it shows increasing returns to scale. Similarly, when alpha plus beta is less than 1, it shows decreasing returns to scale. So that is Cobb-Douglas production function. Definitely, there will be some numerical problems. It is an important topic. We can expect some numerical problems based on Cobb-Douglas production function. So what kind of numerical problems can be asked? Just we have to substitute, mostly we have to substitute the values in the equation Q equals A into L raised to alpha K raised to beta. That kind of questions are mostly asked. So you must be thorough about it, and we can see, suppose a question is asked like the Cobb-Douglas production function is given as Q equals A into L raised to alpha K raised to beta. Derive marginal product of labor and capital. How we can derive the marginal product of labor and marginal product of capital? See, so the production function, the Cobb-Douglas production function is given as Q equals A into L raised to alpha K raised to beta. Then we have to derive the marginal product of labor and marginal product of capital. See, what is marginal product of labor? We have to differentiate the output with respect to labor. That means marginal product of labor equals dQ by dL. The change in output with respect to a change in labor. Then that is equal to, when you differentiate the above this equation with respect to labor, what you will get? A into capital is constant. So A into alpha into L raised to alpha minus 1 K raised to beta. This is the first step. So what is that? That is equal to, what is L raised to alpha minus 1? L raised to alpha minus 1 can be written as L raised to alpha divided by L. So we can rearrange this equation. Alpha divided by L into A into L raised to alpha K raised to beta. So that is equal to alpha by L into A into L raised to alpha K raised to beta. What is A into L raised to alpha K raised to beta? A into L raised to alpha K raised to beta is Q. So what we can write, that is equal to alpha by L into Q. Or we can say it is, that is equal to alpha into Q by L. Alpha into Q by L. What is Q by L? Output, total output divided by number of units of labor. What is that? total output divided by the number of units of labor, that is equal to average product of labor. So that is equal to alpha into APL, alpha into average product of labor, that is the marginal product of labor. So if you are asked to find marginal product of labor, and if you know alpha and average product of labor, then you just multiply it. You will get marginal product of labor. If average product of labor is not given, first you have to substitute the values in this equation, then find the Q. First we have to find the Q, then divide that Q by L, then you will get average product of labor. So in this way you can get some easy questions. So be familiar with this kind of numerical problems. Use some books and do some of the numerical problems and be familiar with it. So it will be easy for you in the exam. Anyway, we can expect some numerical problems. So today we are stopping here. This much only about the production. So we have completed production. Then the next chapter, cost, that we will discuss in another class.